everybody, it's your bro, hope you're doing well, and in this video I'm going to teach you guys about interfaces in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Well, let's talk about interfaces. Think of interfaces as a template that can be applied to a class. It's similar to inheritance, but it specifies what a class has or must do. Classes can apply more than one interface, so that's a key thing to take away from this, whereas an inheritance is limited to just one direct superclass. Here's an example. I have three additional classes. I have a class called Rabbit, a class called Hawk, and a class called Fish. We're going to be creating some interfaces, two for this example, one called Prey and another called Predator, and we're going to have some of these classes implement these interfaces depending on what the animal is. So this is how to create an interface. Go to File, New, Interface, and let's call the first one Prey. And click finish. Alright, so we have an interface called Prey. Public interface Prey. Let's create another interface. File, new interface. This will be Predator. Okay, so we have two interfaces, Prey and Predator. With interfaces, you can declare variables normally like you can do with inheritance. You can also declare some methods, and you do not need to create a body for these methods. So when a class is implementing one of these interfaces, they need to implement and define what this method is going to do. So let's begin with Prey. Let's write just one method. So what's a method that Prey will do? Well, Prey flee from predators. So let's create a method called flee. This will be void flee, and that's it. We do not need a body. So void flee, that's it. There is no body to this. And And let's say that our rabbit is going to use this interface. Now to implement an interface, when you define the class, just type implements, then the name of the interface. We would like to implement the pray interface. Implements pray. So one thing with interfaces, if you declare a method, it works like an abstract method. We need to define what this method is going to do. So within the rabbit class, we need to add any unimplemented methods. So we're basically overriding this flee method. So what do we want our rabbit to do when we call the flee method? So maybe just a simple system.out.println that states the rabbit is fleeing. And let's test this. Hey, what's going on? Hey, what's going on? Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about interfaces in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Well, let's talk about interfaces. Think of interfaces as a template that can be applied to a class. It's similar to inheritance, but it specifies what a class has or must do. Classes can apply more than one interface, so that's a key thing to take away from this, whereas an inheritance is limited to just one direct superclass. Here's an example. I have 3 additional classes. I have a class called Rabbit, a class called Hawk, and a class called Fish. we're going to be creating some interfaces, two for this example, one called prey and another called predator, and we're going to have some of these classes implement these interfaces depending on what the animal is. So this is how to create an interface. Go to File, New, Interface, and let's call the first one prey. And click Finish. Alright, so we have an interface called prey. Public, interface, prey. Let's create another interface. File, New, Interface. This will be predator. Okay, so we have two interfaces, prey and predator. With interfaces, you can declare variables normally like you can do with inheritance. You can also declare some methods, and you do not need to create a body for these methods. So when a class is implementing one of these interfaces, they need to implement and define what this method is going to do. So let's begin with prey. Let's write just one method. So what's a method that prey will do? Well, prey flee from predators. So let's create a method called flee. This will be void flee, and that's it. We do not need a body. So void flee, that's it. There is no body to this. And let's say that our rabbit is going to use this interface. Now to implement an interface, when you define the class, just type implements, then the name of the interface. We would like to implement the prey interface. Implements prey. So one thing with interfaces, if you declare a method, it works like an abstract method. We need to define what this method is going to do. So within the rabbit class, we need to add any unimplemented methods. So we're basically overriding this flee method. So what do we want our rabbit to do when we call the flee method? So maybe just a simple system.out.println that states the rabbit is fleeing. And let's test this. Let's create a rabbit object. Rabbit, rabbit, equals new rabbit. And let's see if we can call that method rabbit.flee. There it is. The rabbit is fleeing. Now let's apply the predator template, well, interface, to the hawk class because hawks are predators. They are very rarely prey. Well, I could be wrong. Alright, so public class hawk implements predator, and we should probably create a method within predator for this example. So if a animal is a predator, they should have the ability to hunt. So let's create a method called hunt. Void hunt. And we do not need to declare a body. So within our hawk class, we need to add any unimplemented methods and define what this does. Within this implementation. So let's say if the hawk object is going to use the hunt method, we will display the hawk is hunting. And let's create a hawk object this time. So hawk equal new hawk. Hawk dot hunt. The hawk is hunting. Now, since we're implementing the predator interface, there is going to be no flee method for hawks because we're not using the prey interface, we're using the predator interface. So just to prove that, we'll attempt to use hawk.flee, and it doesn't appear that there's a method for that. Yep, method flee is undefined for the type hawk. Alright, now we can apply more than one interface to a class. So with fish, fish can be both prey and predators depending on their size. Bigger fish tend to eat smaller fish. So let's add two templates, two interfaces to our class fish. And this is how to do that. Implements prey, comma, predators. So we're applying both of these templates, these interfaces, to our class fish. So we're implementing prey and predator, but we need to add any unimplemented methods, and we have two this time. One hunt from the predator interface and another flee from the prey interface. So let's define these. So system.out.println within hunt will just state that this fish is hunting smaller fish. And with the flee method, system.out.println, let's say this fish is fleeing from a larger fish. And let's try this. So let's create a fish object. Fish fish equals new fish. Fish dot hunt. So our fish has a hunt method. The fish is hunting smaller fish, and it has a flee method, fish dot flee. The fish is fleeing from a larger fish. So in conclusion, an interface, think of it like a template that can be applied to a class. It's similar to inheritance, but it specifies what a class has or must do, and classes can apply more than one interface, and we did that with our fish class. It's implementing both the prey and the predator interfaces, so it has access to both of these methods, but it needs to actually implement these methods by overriding these methods. So that's the basics of interfaces in Java. If you'd like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how interfaces work in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about polymorphism in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Polymorphism. This is a Greek word for poly. It's the ability of an object to identify as more than one type. Think of it as being identified as more than one data type. Here's an example. Let's say we're going to have a race, and we can enter in all different sorts of vehicles into this race. They don't all have to be the same. So we have a few additional classes. A class called vehicle. Vehicle is going to act as the parent class for my class car. So car extends vehicle. Bicycle. Bicycle extends vehicle, and boat. Boat extends vehicle. So car, but Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about polymorphism in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Polymorphism. This is a Greek word for poly, meaning many, and morph, meaning form or forms. It's the ability of an object to identify as more than one type. Think of it as being identified as more than one data type. Here's an example. Let's say we're going to have a race, and we can enter in all different sorts of vehicles into this race. They don't all have to be the same. So we have a few additional classes. A class called vehicle. Vehicle is going to act as the parent class for my class car. So car extends vehicle. Bicycle. Bicycle extends vehicle, and boat. Boat extends vehicle. So car, bicycle, and boat are all subclasses or children classes of the vehicle superclass. So let's create an instance of our car, bicycle, and boat. Luckily, through the magic of copying and pasting, I have done that already. We have a car object, a bicycle object, and a boat object. So let's store, well, at least attempt to store all of these objects within an array called racers. Racers equals, and then we will place our car, bicycle, and boat within this array. So what's the data type of this array going to be? Well, we're going to have a problem. Could we make this cars? Well, we could store our car object within an array of cars, but not our bicycle and our boat. The same thing goes for bicycle. We can store our bicycle, but not the car and the boat. And lastly, with the boat data type, we can store the boat, but not the car and the bicycle. And to solve this issue, we can use the power of polymorphism. So, for example, our car identifies as a car, but since it extends the vehicle class, it also identifies as a vehicle. Same thing goes with our bicycle and our boat. So, one thing they all have in common is that they are all vehicles, so we can change the data type of this array to vehicles. And therefore, we can store our car, our bicycle, and our boat, because all of these objects also identify as vehicles. So if you're going to store objects within an array, and they're all different object types, you would have to find what they have in common and make an array of that type. So that's how to store different objects within an array using polymorphism. And now for our arrays, we're going to call a go method that we're going to define within each of our classes: car, bicycle, and boat. So let's begin with car. Let's create a go method. So let's make this public, void, it's not returning anything, and this will be called go. So when we call this method, all we'll do is have a printline statement, system.out.println. Let's say something like, the car begins moving. Okay, let's repeat the process for bicycle and boat. Let's change car to bicycle. And within the boat class, car to boat. So each of these methods, well, each of these classes has their own go method, and we could call them individually kind of like this: car.go, bicycle.go, and boat.go. So this would work, but there's actually a better way to write this. And what would be better is if we were to create an enhanced for loop to iterate through all of the elements of this array of vehicles. So the data type for this enhanced for loop is going to be vehicle. We'll use x as our counter, colon, and then the name of the array, which is racers. So this is going to iterate once through all of the elements of this array of vehicles called racers. X represents the vehicle we are currently working with. So x dot, and we would like to use the go method. So our enhanced for loop doesn't care what kind of vehicle. You are, if you're a car, a bicycle, or a boat. It cares that you're a vehicle, and if you're a vehicle, use your go method, whatever kind of vehicle you are. So there's one more step to this too. The method go is undefined for the type vehicle, so we need to make sure we have this go method within our class of vehicle, and I just generated that here. So what we're doing is actually method overriding within the car, the bicycle, and the boat class. So this isn't necessary, but it's considered good practice to add the add override annotation to each of these methods. And then our enhanced for loop is going to iterate through all of the elements of our array of vehicles called racers. So it doesn't care what kind of vehicle you are. If you're a vehicle, use your go method. Well, luckily our car, our bicycle, and our boat all also identify as a vehicle. So that's all that polymorphism is. It's the ability of an object to identify as more than one type. Think of it as identifying as more than one data type. Our car does identify as a car, but it also identifies as a vehicle. Same thing can be said with our bicycle and our boat. But not only that, all objects are children classes of the object class, so they also identify as objects. So you could write this using the object data type, but there's a few other changes that we would have to make. So that's all that polymorphism is. It's the ability of an object to identify as more than one type. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of polymorphism in Java.